Namaste, Namaskar, and Vanakkam again. Welcome back to Jal Prayag. I'm planning to do a quick video, but this time I'm going to change the topic right now. I'm going to start something called running fix. I had mentioned about this that I'll be doing running fix since I had done earlier simultaneous fix. So let us look at the basic concepts of running fix. I can bifurcate them into many sections. So right now I'm choosing one kind of running fix. So let us have a look on this concept. If you look at the topic, I'm using a running fix. I'm calling it first video. Why? Because there'll be a couple of series of videos of running fix. Running fix is a little bit bigger topic. Why? Because you can involve many features. So I'll be talking about those features also. But this time I'm going to use only position lines. So let us have a look on what is the definition of running fix first of all. You had already seen what is the definition of simultaneous fix. Now, when two or more fixing tools are given to you at different times, then it is called running fix. Using geometric principles of triangles and parallelograms, I can still find both the fixes for me at two different times. Now, running fix can involve current, it can involve wind and current, or it may not have any environment forces also. So I'll be starting with no forces, and then I'll slowly build up on different forces. Now, since I can use current and wind, you will see that I'll be forming the basic chart work triangle, which we have already seen. So we'll be having a repeat of chart work triangles. So the moment chart work triangle comes, I can broadly categorize into allowing and counteracting method. We have already done allowing method. Now, what all fixing tools will you use? Now, it could be two PLs or two bearings. It could be two ranges also. And it could be combination of one range and one bearing as well. So based on the data given to you and the type of question, your procedure will slightly differ a little bit. You will have some restrictions. So we will see how to go one by one, but this module I am looking only at running fix using PLs. And the first case I've taken is I'm not involving any environmental forces. So there's no current, no wind. Okay, it's always best for me to start with a small example. So I've taken a small example. Let us say a vessel was sailing and Bill of Portland at 8 o'clock was bearing 030 true. And again, the same lighthouse was bearing 330 degrees true. While on this, during this time, so the CTS was 060. And let us say the engine speed was 12 knots. Question is to find both 8 and 9, 9 o'clock and 8 o'clock positions. Let us quickly look into the concept. Now, before I start, word of caution. Remember, bearings are always measured at the vessel because you are at the vessel. And you always measure it from you to that object. Your object is your lighthouse, which is your Bill of Portland. But what happens when you go to the chart? When you go to the chart is empty. You only have Bill of Portland. You don't know where you are. So you don't draw 030 from Bill of Portland. Please remember, you will draw exactly the reverse, the reciprocal of 030 from the Bill of Portland. You'll mark it with a single arrow wherever your line ends, showing you the symbol of PL. So this point is important. Why? Because I have mentioned this before also. A lot of beginners do this mistake. So I'm going to show you on the chart part of it also. Let me show you. Let us quickly start. We know what is PL. PL is always a line on which your vessel's positions can be found out. So if you agree, I have drawn a reciprocal of 030 from Bill of Portland. And please mark the timestamp, mark the small arrow at the end of your line. And let us consider your vessel was here. So you can see bill of port land is 030 from your vessel. Similarly, you could be here, you could be here, anywhere. So still answer is same. Similarly, please do not draw 330 from bill of port land. You'll have to draw the reciprocal timestamp. And again, I can consider anywhere on this line. Any place you will still see bill of port land will be 330. Okay, these diagrams are depicted, so it is not exactly measured. So let us later on quickly see on a chart as well. So when I continue this question, how do I do a running fix? My first job is to choose any point on the first PL. So I call it alpha. It can be anywhere. It could be anywhere. It is also called as assumed point. So I'm choosing an assumed point alpha anywhere on my first PL. I'm going to run my vessel thinking that it is here. So I'm going to run my vessel with a course given 060. I'm going to use the engine speed, but for how long? That how long is defined by the duration between the two PLs. So you can see it is 8 and 9 o'clock. So it is 1 hour. So I'm going to take 1 hour, which is 12 nautical miles. Please mark 12 nautical miles and call that Bravo. Alpha and Bravo are not any positions. Please remember, you have started from an assumed position, so they are not. So what is your next step? Next step is transfer your first position line to Bravo. So I'm going to take a parallel ruler. I will move it. I'll get it here. And I'm going to mark this with a different symbol. I'm going to put double arrows on both the sides. So which clearly means it is an indication of a transferred PL. So you can see I've done a transferred PL. So for me, the next step will be wherever this transferred PL intersects the second PL. Please remember, this is a transferred first PL. Wherever it intersects the second PL, that is my fix at 9 o'clock, which is your second fix. So I already got your second fix. Then how do I find 8 o'clock? I already know that I have traveled 060 at 12 nautical miles. You can use the same parallel ruler, put it on the CTS and bring it down and mark it at 0900 fix. So bring it here. You can see this line is going to go and intersect again back on the first PL, and that is going to be your 8 o'clock fix. Please mark your symbols of CTS, which is your single arrow. You should observe that I have formed a parallelogram with the two CTS and the two PL, that is the first PL and the transferred PL. And the two CTS what I have drawn, one from the assumed position, the other from your actual position. Your actual position is your fix. This gives you a small clue, and which is very evident that I could have started alpha anywhere on my first PL. I will still get the same answer. I'm just showing you one small intermediate position. I could have started alpha even from here also, and I would have got the same answer. So please don't bother. You can choose alpha anywhere in the first PL. So never bother. You can choose anywhere. I'm going to show you the same question on a piece of chart. I've shown you bill of port land. Please look at the steps. Draw the first bearing in the reciprocal direction. Mark an arrow here. Timestamp it. Do not draw 030 from here. The second PL, mark it again from bill of port land in the reciprocal direction of 330. And do not draw 330 from your bill of port line. So this, please remember, it is important. Now, I assume a position alpha anywhere on the first PL, draw my CTS, measure 12 nautical miles, mark it Bravo, transfer my first PL to Bravo, Mark it with double arrows on both edges. Wherever the first transferred PL intersects the second PL is your second fix. Where is the first fix? Please transfer your CTS back. You'll get it. So you have the 8 o'clock fix. So actually what was happening was vessel was here and it traveled like this. So what you have done is you have found out where are the two actual positions because of the data given to you. So you will realize that only at this one place, which is your 8 o'clock and 9 o'clock fix, you can match both the bearings, you can match your CTS also, and you can match your engine speed. So this is what is the use of your parallelogram structure where I had transferred my PL. I'm going to go for a slight variation from this first example. I'm still using PLs, but I'm giving you different lighthouses. So please see here, question is very similar. Lighthouse X 030, lighthouse Y 330, but they are different times. Engine speed and CTS are same for convenience. Again, I'm asking you the same thing. Let us quickly have a look. Two things you should realize. I have two different bearings, so it is a running fix at different times. I have two different lighthouses. Process is very, very similar, so I'm going to be a little bit fast. Process is very similar, except that the second PL, what you're drawing is from a different lighthouse. So I'll just quickly take this as the first lighthouse, and this is the second lighthouse. First PL drawn reciprocal, second PL also drawn. Assumed position A as usual before, the same thing on the first PL. Draw the CTS, measure the engine speed for 1 hour, mark Bravo. Please transfer the first PL with double arrows. Intersection gives you a fix. Retransfer back your CTS because this is how you travel for last 1 hour. And there you go. So this is example with two different sources. Let me show you the same example on a piece of chart. I'm going to take a different piece of chart. I'm going to consider two different lighthouses. The first one, let me call it Wolf Rock. Second one, let me call it Lizard Point. So I'm starting with my first PL, second PL. Please do not draw this. Again, word of caution. I take a assumed point, let us say alpha. I'm going to draw my CTS, mark 12 miles, that will be Bravo. Take a parallel ruler, transfer the first PL to B. So that is what is your transferred PL. Wherever you got intersection is your second fix. Now again, take the parallel ruler, please put it on the CTS, transfer it to the 9 o'clock fix. You will get 8 o'clock fix, and you will see the vessel was moving like this. So this is an example with two different lighthouses, two PLs. Let us look at one more case, and this time I'm going to add current. So one of the environmental forces, I'm going to add it right now. So you can see I'm still using two PLs. This time I'm going to use only current. So let us have a look. Please look at the data. Very similar. I'm not changing data for the ease of construction and working on my PPT and understanding also. Same bearings, 8 o'clock, 9 o'clock, same course and speed, but this time I'm going to add set and rate. The question is again, same thing. The moment you put any environment, we already seen that we will be forming a chart work triangle. And you can see CTS and engine speed are given, so that means it is an allowing method. Okay, so if you remember from the previous basic chart work triangle problem, how to do the allowing method, I'm going to show you them. Same steps are same. So let me start again with choosing a point A on the first PL. Please draw the CTS. Mark it for 1 hour. Why? Because the two PLs are 1 hour away. And I'm going to mark Bravo. But Now this is the time I need to add my current also. So from Bravo, please apply the current and come to a point called Charlie. You can complete the triangle by joining alpha and Charlie. So you have completed a chart work triangle. Let us say this hypothetical answers were 08012.5. Now from here onwards, again follow the same steps. Transfer the first PL to Charlie now. If you remember earlier, I was transferring it to Bravo because I did not have current, but now I have to transfer it to Charlie. The point of intersection obviously is your fix. Now you'll have to be careful. I want to find 8 o'clock fix. So what should I transfer? How do I get the 8 o'clock fix? I've been telling this again and again. The position of vessel is always found only on the CMG track. So you already have a position here at 9 o'clock. So that means you should transfer only the CMG track at 9 o'clock. So your colors are helping you to understand much better rather than getting confused. The CMG, I can transfer only CMG, nothing else. Okay. And this will give me one more fix. If you realize now, I'm still forming a parallelogram, but this time I'm forming a parallelogram with CMG track. Okay. This is something important. Please be careful. Okay. Now I'm going to show you very similar, but don't forget the arrow symbols. For me in this PPT, I'm showing you a solid triangle instead of arrow because it's easy for me to draw a solid triangle, but you guys have to just show a simple symbol of your arrow. Just put a simple symbol of arrow, single arrow, double arrow, 3 arrows, whatever it is. Now let me go to the, this is the last slide. Let us quickly look on the same example, which is involving 2 PLs and current. So again, I'm starting here, first PL, second PL, assumed position alpha, CTS, mark your Bravo with 12 nautical miles. Please apply the set and rate because it is for 1 hour. The whole triangle is going to form for 1 hour. Arrive at Charlie. Transfer the first PL. I'm sorry, before that you can complete your CMG also. It's fine, no issues. Even then you can transfer, but it's preferable. Let us complete the triangle. Mark all the symbols. And I do transfer it now with double arrows on both the sides. Intersection is your fix. Here again, as I said, careful. Please transfer only CMG because vessel's position is always on the CMG track. And you are here at 8 o'clock. So what was the vessel doing? The vessel was steering 060 like this, but it was being pushed by the current, so it was having a different CMG track. So this is what we call as running fix. I've taken a few cases of running fix what I showed you, but I have taken only PLs. I'll be making the next video where I'll go into position circles, which is called ranges also. I'll be doing a running fix on that. So what we saw here today was using PLs. I used a case where there was no environment. Then I used a case where 2 different lighthouses were involved. Then finally, I took a case with current involved, which is using your alloying method. So that's it for today. It was a small video. Hope it was useful. And keep watching Jal Prayag. I'll come back soon with the next video of running fix. Until then, Vanakkam, Namaste, Namaskar.